Hey guys, welcome to the second part of the slab design tutorial. In the previous tutorial, that is the first part of the tutorial, we just discussed about how to assign the design strips manually in each slabs. So in this tutorial, we will be discussing another method which is much more easier, that we are going to assign the design strips automatically with the help of Etabs with respect to the grid coordinates that we have assigned for our model. So if you just go to the view and just select the set grid system visibility, you can see that I have already assigned the grid lines, and with respect to that I have modeled my building. And you can find that each of my beam has been passing through each of the grid line that has been assigned in both X and the Y axis. So if you want to know more about the assignment of the grid lines, you can just check out the beginners video tutorials in my YouTube channel Civil Know-How Tutorials, where I have explained the grid line assignment in a video named Modeling of a Commercial Building. So now let's change the visibility and let's go to adding the design strips automatically. So for that, let's go to Edit and select the Add Edit Design Strips and click on Add Design Strips. So here in this dialog box, in the tower, let us be T1 itself, and here I'm going to design my slabs in the third floor, that is F3. And here under Options, just select Add Design Strips along the Cartesian grid lines, and also we need to include the middle strips, so check this box. And the parameters is that the grid line, that is the coordinate system, is grid 1. This is the only grid system that I have assigned for my model, so I just select grid 1. And the grid direction, for this time I'm going to select it as X, and the layer is A, so I'm going to assign strip layer A with respect to X direction. And I leave the strip width as an auto option and click on Apply and OK. So here you can see the strip layer A has been assigned by Etabs along the X direction automatically, which is passing through the entire slab. So in similar manner, we need to assign the grid line B along the Y axis or the Y direction. So let's go to Edit and just repeat the same step, Add Design Edit Strips. So here we need to change under Parameters, change the grid direction to Y and the strip layer to B, and leave the strip width as auto itself and click on OK. So now you can see another strip layer B in the direction Y has been assigned also. If you can just go to the display options and just select the other assignments and show width, you can see the strip width has been assigned. So this is a graphical representation of the strip width. So here I'm switching off the show width option and click on OK. And next what we have to do is we have to design the slab. So before that, I would just like to say that I'm going to design the slab with the first combination, that is the combination of dead load plus live load, and I'm using a factor of 1.5. So if you just go to Define and Load Combinations, I have already defined 9 load combinations with a envelope combination, that is combination 10. For this tutorial, you don't have to be bothered about combinations other than combination 1, because for the slab design, I'm just considering the combination 1. If you just check the Modify Show Combo, you can find that the combination is dead plus live plus masonry. So here, after the assignment of the strips, we right now analyze our model and click on Run Analysis. So now we have finished analyzing our model, and after the analysis, let's go to the design, and under design, select the concrete slab option, that's the concrete slab design, and let's first select view or revise preferences. And over here, the first thing we have to do is that if you're using the ACI code, you can use the ACI code, but now I'm going with the Indian code, that is IS456. So I'm just selecting IS456 2000 from the drop down that has been provided under the design code. And here you can see under the factors, the gamma steel and gamma concrete is being given as 1.15 and 1.5. These are actually the default values. And next here we'll go to the minimum cover that we're going to provide for our slabs. And here I'm going to give a clear cover of 20 mm. and 20 mm over here also. And if you can just see the preferred bar size, the bar size that has been given over here, these are all the imperial sized bar size, but we need the metric one. So here for time being, I am using a 10 mm diameter bar, and the equivalent imperial size is diameter 3. So I'm going to select diameter 3 for my slabs. And the inner slab rebar layer has been selected as layer B itself. And we will just keep the rest of the values as it is. And here the type of minimum reinforcing that we are going to provide for a slab is 2-way. And after we are done with this, let's click on OK. And over here you can see a shortcut menu for the slab design. That is over here. So you can just go directly to the concrete slab design by clicking over here. And over here, next what we have to do is that we have to select the stories, that is for designs. So here I'm selecting the floor F3, that is the third floor, and click on OK. And if you go to the concrete slab design again, let's select the design combinations. So here I'm going to select the combination 1 as my design combination, that is I'm going to design my slab for the gravity load, that is the combination 1, and click on OK. And after making the necessary assignments, let's now go to the start design option. So this will start the design of the slab. So now the design is being done for the third floor of our building. And if you just run our mouse to the design strip, you can see the area of the top and the bottom steel that is being described over here over each strips. So here, that for time being, the strips that is being assigned as a strip layer A along the X direction. If you just go to the design slab option and just select the display flexural design, you can see that the display type is being chosen as a default as strip based, and the display type is an enveloping flexural reinforcement, and the rebar location shown is show top bar and the show bottom rebar. And the reinforcing display type is show rebar intensity by area by unit width. Now let's select the second one, that is showing the total rebar area for each strip. And we're going to choose a strip direction as layer A itself and click on OK. So now you can see the rebar area is being shown with respect to the strip width, not per meter square. And if you go to design again and select the display flexural design, now let's change the display type of the reinforcing from show total rebar area for strip to show number of bars of size. So here I'm going to provide the default size as diameter 3 and the diameter 3 for both top and the bottom. And this time let's select for the layer B and uncheck the layer A. And click on OK. So over here you can find that the design strips has been assigned along the layer B in the Y direction. And here you can just see that now instead of the area, right now the design strips are showing the number of bars at top and at the bottom. So these are the 3 different types of display type that you can opt. So you can just select anything according to your wish. And next, if you just go to the show rebar above specified value, here by default we have selected none, but right now I'm going to check the typical uniform reinforcing specified below. And here under this option, I can just check for the certain amount of reinforcement that has been present above the values that I'm going to provide over here, top and bottom. So from the analysis results, I just want to see the bar size of diameter 3 in top and bottom, more than 150 mm. So now Etabs will only display the number of bars that are exceeding these specified limits. So let's click on apply and OK. So these are the areas where the number of bars are being exceeding from the specified limits. And now let's go to the design of the slab again and select the display flexural design. Till now we were discussing about slab design based on strip area method. And now let's move on to the second method, that is the finite element method. So here we will keep the display type as enveloping flexure reinforcement, and you can also select the contour range, but I am going to leave as 0 for both minimum and maximum. And here the contour averaging at nodes, I am going to select it by objects. And here for the time being, I am going to select the reinforcing direction and location as direction 1, that is top rebar. So I just want to view the top rebar only. And here under show rebar above specified value, this acts as similar to what I have shown you before in the strip area method. But for the time being, I am just selecting none because I just want to view the every value, not just a specified set of values. And let's click on apply and OK. So the FEM analysis is being done on the third floor, and if you just move the cursor, you can just see the top rebar area along the direction 1 being shown in mm square per meter. So you can also do the similar thing along the direction 2 of top rebar. Click on apply and OK. So this is along the direction 2. And you can try this with respect to the bottom rebar along the direction 1 and the top rebar along the direction 2. And under show rebar above specified value, if we select the typical uniform reinforcing specified below and set the bar diameter as 3 with 150 mm spacing at both top and bottom and click on apply, you can see as per the FEM analysis, the area where the reinforcement is exceeding as per the specified limits. This comes to the end of this tutorial. If you find this tutorial useful, please do like, share and comment on this video. And do click on this logo to subscribe to our channel for our upcoming tutorial videos.